Okay, here we have another Hess's Law example. This is video F. This is the last one in part 2 of our series of lectures on chapter 6. Okay, so we're trying to find the delta H for an unknown reaction, and we're given 3 reactions to work with. Note that sometimes you won't need all the reactions you're given, which makes a question kind of tricky. In this case, we are going to need them all. So let's go ahead and take a look at how we can do this. It's trial and error, and I'm just going to walk you through my thought process. I'm going to go ahead and start with this second reaction because I see something I definitely know I need. I definitely need the N2O5. I need it on the right, and I need 2 of them. So I'm going to take this and I'm going to flip it, and I'm going to double it. So when I flip it and double it, let's see, N2O5, that gives me 76.6 times 2, 153.2. Okay. So now I have HNO3, I have 4 of those, gives me 2 waters and 2 N2O5s. Okay, that was from this one. Then let's look at the second one. I know I'm going to need HNO3 on the right to get rid of these because I don't have that in my final reaction. I'm also going to need some dioxygen on the right side, and I need dinitrogen on the right. It would be nice to have 2 of these. So I'm going to go ahead and I'm sorry, let me back up a second. I know I need this on the left, and it needs to be doubled. I know I need to cancel this here, and that's going to need to be doubled. So I'm not going to flip this one, I'm just going to double it. Sorry, I think I misspoke on that. So I'm just going to double this. So I'm going to keep my arrow right below my other arrow, and I'm going to put 4 HNO3s here, then 2 H2s, 6 dioxygens, and 2 N2s. Okay. So when I double that, I get negative 696.4. Okay. Now I can see these are going to cancel. I'm going to have my 2 N2s, so I've got that. I'm going to have my 2 N2O5s. I have that. I'm going to need to get rid of some waters. So these 2 waters are going to have to go away. You can look at this third reaction and see that I have water on the right side, and I really would like it to be on the left, and I'd like there to be 2 of them. So I'm going to flip it and double it. And when I do this, by the way, I just do the thought process I mentioned, and I don't really worry about what happens on the other side because these all have a way of working. They're all going to work for you somehow. They're designed to do that. So just follow these clues that you're going to see as you go, and they have a way of just kind of falling together. Okay, so what did I do? I flipped that one and I doubled it. So that gives me, let's see, 285.8 times 2 is going to be positive 571.6. And in a minute I'm going to add those together. Okay, let me just check and see what's going on here. So now I can cancel my dioxygens, and what else can I get rid of? Well, look, I can get rid of 1 oxygen here. That's going to make this a 5. And then my 2 dihydrogens cancel. So what have I got left? I've got 2 N2s plus 5 O2s. And on the right, I have 2 into O5. That is my desired reaction. Okay, great. So now I add these together and I get 28.4 kilojoules per mole. So I can see that my net reaction is, let's see, 28.4. Okay. I'm just going to double check my math on that. 571.6 plus 153.2 minus 696.4 gives me 28.4. Okay, so this is endothermic. And that is my delta H. So this is the very end of this second lecture, part 2 of chapter 6 for 323. And so I'm going to stop here, and the next lecture you're going to see is going to see part 3, chapter 6, and we're going to pick up where we left off here, and you're going to see video G. And I'm going to keep going up the alphabet until we go on to the next chapter, which is going to be chapter 18. But you can always know where you are by keeping an eye on the date, and that's going to show you which lecture it is.